So, as the sun sets over the Kerbal Space Center, we begin the next stage of our moon survey. The goal today is to take our vehicle, the Munar Station 1, to the moon, then put the mapping satellites into orbit, and get everything settled for excursions to the surface. The first step is to find the moon, right there, and then to set up our encounter node. So to do that, we add a maneuver along the orbit and to move it around until we get an encounter with Moon. Okay, that gives us an encounter over the Munar South Pole, approximately 200 kilometers away. For this, we're going to want a really highly inclined orbit so that we can drop off the mapping satellites, and just that so that we can reach all altitudes with our biome survey. So I think I'm going to go with an approximately with about that orbit. Pretty much everything rotates counterclockwise on this map. So moon goes that way, and it'll be rotating that way as well. And we want to get our orbit so that we're going with it. And I think we're good. Yes. So we're on a highly inclined, halfway between polar and equatorial orbit. Good. That burn looks like it'll do the trick. So let's line up our encounter nodes and then do the burn. Okay, burn will take approximately 1 minute and 5 seconds. We will start our burn at about 30 seconds to our encounter node. So, 3, 2, 1, begin transfer burn. Okay, let's see what the damage is. We are a fair bit off course, but I think we can correct it just by good. Our estimated moon periapsis is now 1.1 million meters, but that should be pretty easy to fix. 600 kilometers, 400 kilometers, 300, 200, and I think that's as good as we're going to get. We'll have to do a mid-plane course correction to get ourselves closer to the target. The green marker there is where the orbits intersect, so that's the best place to do it. Course correction in 2 minutes, 1 minute, and slowing down. Course correction in 20 seconds. And gentle burn. New lunar periaps, 55 kilometers, but we can reduce that a little. Let's aim for 30. 25 it is. Now, set up an alarm clock node for 4 hours from now. Now we are high above the moon. Kerbin off in the distance there. The sun, Kerbal, and moon. When we get hit our closest approach, we are going to thrust retrograde and circularize our orbit. Our periaps will be at an altitude of 25,000 meters. Let's get ourselves oriented before we have to make our maneuver. Let's speed back up again. Now for this initial orbit, I'm going to aim for a high point of around 150 kilometers, and I'm going to release all 3 satellites spaced along the orbit. So I'm going to release all 3 at the top, the apoaps of the orbit, then from there circularize each of them, spacing them around in a polar orbit. plan out the circularization burn. Let's say okay, 300 meters. That will be an 11-second burn, or 150 meters per second. Good. Node in T minus 50 seconds. 40, 30, 20. Start burning in 5, 4, 3, 2, 1. Apoap's 1,900,000, 700 kilometers, 600 kilometers, 500, 400, 300. That'll do. Now, that looks like a polar orbit inclined about 15 degrees. Pretty much perfect. The reason we want an inclined polar orbit as opposed to a perfect polar orbit is that we want to scan the entire surface, and if you are in a perfect polar orbit, you're going to miss spots around the poles. So you're wasting quite a lot of scanning ability. Alright, time to apoaps. 43 minutes. Let's quick save that, and actually it turns out that the ethane scanning range for the compact unit is 250 kilometers, so I'm going to take it down to 245-ish. Now, we want to contact okay. I'm going to activate all of these little satellites and tell them to talk to the satellite that's currently over the Kerbal Space Center. That way we have communications. And then I'm going to go to the satellite currently over the Kerbal Space Center and to point it to the moon. And voila, we have a connection. There we go. 248 by 236 in a 2-hour orbit. That should be pretty good. Let's activate our mappers. Status active. Hooray. And our map of the Munar surface has begun. Let's switch back to the other craft and do the other two maps. It will look exactly the same as this, so I will pause the recording. Now that the Munar satellites are in place in a nice organized equilateral triangle, the next goal is to get our Munar Station into a more equatorial orbit. It doesn't have to be a perfect equatorial orbit, it just has to be better and closer to the surface. So we're going to burn probably most of our remaining fuel getting into it. Our first burn is to change our inclination to about 45 degrees. That will cost us 300 meters per second. Inclination 45 degrees. Mark. Periapsis at 81. Let's slow that down and bring us back down to 26. I could probably have planned that maneuver quite a bit better. Apparently we've got a 22 periapsis then. I'm adding a new alarm for the periaps. That way it automatically stops when I get there. Perfect. Now let's slow us down and bring our apoaps down to 22 as well. Ish. The tallest mountains on the moon, I think, are 8 kilometers high, so any orbit over 8 kilometers is just fine. Our periaps appears to be dropping. Ah, that's why. Let's just catch up a little bit. A 19-kilometer orbit then. All right. Parking orbit achieved, 19.6 kilometers by 19.5 kilometers, and that should do us for today. Now it's all over but for the video editing. That's the fun part.